Right now, we're going to focus on the history and the discovery of the atom. Just like in other discoveries and looking at the technology or knowledge that we may have today, none of that could have been achieved if it weren't for the people in the past in which they may have discovered something and then other people who came after them used their knowledge and was able to build off of it. So that's something that you're going to see in today's video and PowerPoint. The first man we're going to focus on was Democritus. Democritus was an ancient Greek philosopher living around 430 BC, which is before Christ. And basically, he came up with this idea with only a few other philosophers that believed that all things were made up of these little tiny hard particles that could not be broken down or divided any further. He used, in Greek, he came up with this word atomos, and that's where we get our word atom from. And atom, or atomos, means cannot be cut or cannot be divided any further. He came up with this idea of these small hard particles, generally spheres, and this was actually not a popular theory, even though it was somewhat correct. Basically, this was in the time of Aristotle and Plato, and basically they believed that all life, living and non-living, were made up of just four basic elements: earth, wind, fire, and water. But he kind of went against that idea, believing that all things were made up of these little particles. Now, actually, it wasn't until John Dalton, which is in the early 1800s, that Democritus's idea actually was even agreed upon. And so this is almost 2,000 years later. Now, John Dalton was known as the father of the modern atomic theory. He came up with the idea that all elements were made up of atoms, which is true. He came up with another idea that all atoms of the same element are exactly alike. So all atoms of oxygen are going to be the same, and that's true based on the number of electrons and protons. Generally, all atoms of oxygen are going to be the same. And then if you have iron, all atoms of iron are going to be the same. He also said that atoms of different elements are different, and all that means is atoms of iron are different from atoms of oxygen. Atoms of oxygen are different from atoms of chlorine. And then he came up with the idea that compounds basically are formed when two or more elements, atoms, are combining. Okay, when they combine, they form a compound, and that is true. Now, he proposed a very basic periodic table, and you can see at the very bottom here, he kind of drew what he thought they would look like or be a symbol for, and so we have a very basic, very brief periodic table, nothing like what we have now with generally the main symbols. He did use some basic symbols, as you can see, for gold, platinum, and silver with letters, but the others have patterns and designs for their symbols. Now, after John Dalton came up with this idea in the early 1800s, it was progressed a little further through experimentation. And the first guy that we're going to focus on is William Crookes. William Crookes basically came up with this glass tube apparatus, this glass tube structure, and by creating this, he hooked up electricity, and he was able to create inside the glass, create a gas. And when he ran the electricity through, the electricity moved from one end of the glass tube to the other end. It moved from the negative cathode towards the anode. Now, the anode is positive, so negative to positive, that's just like in a battery or in a circuit. But as the electricity moved, as the beam of electrons moved through the gas, it went straight through. And the beam of electrons actually basically couldn't kind of turn in time to the little anode. It would go straight through and it would hit the cross, okay, that little cross object, and it would create a shadow. Well, by doing that, by emitting those rays, those cathode rays, a lot of people would look at this experiment and say, oh, it's just a flashlight, it's just light. But really what it was actually a beam of electrons. It wasn't a flashlight. And the reason for this is what we found out with the next man, J.J. Thompson. J.J. Thompson used a magnet. And as he used a magnet, he actually put the magnet towards the beam of electrons. And when he put the magnet near the beam of electrons, the beam would move. So that beam, okay, he didn't know this at this time, but the beam is, if they're electrons, it's negative, right? Electrons are negative. So if he put the positive end of the magnet near it, okay, the beam of electrons would go towards the magnet. If he turned the magnet over, he'd put maybe the negative end near the beam of electrons. The beam of electrons would move away from the magnet. This shows that it was not light. Okay, and he proved William Crookes' idea, his theory, to be correct, that they were actually a beam of electrons. And a lot of people didn't believe William Crookes' idea until J.J. Thompson's experiment. And so what we have here is, if we look back to Democritus, Democritus just thought an atom was just a sphere, just a hard circular substance. But when we move towards the middle 1800s, we now have some knowledge from William Crookes and J.J. Thompson, which proves, even though we really can't see this in a microscope, that there are negative particles. So what J.J. Thompson did was he created, and you can see this little circle in the middle of the PowerPoint, he created this little diagram that has a little circle, just like what Democritus came up with, but he put these little negatives inside what he believed would be the electrons, right? And he thought everything else would be positive, so that there would be these little negative parts, and everything else would be positive inside the circle. He called this, and this was commonly called, the plum pudding model. The plum pudding model. Now, you can also call this a chocolate chip cookie model. Now, plum pudding is kind of like fruit cake. And so that's why there's a little picture of fruit cake. And you have the little fruit pieces or the raisin. That would be represented by the electrons, those little minuses. And then the cake, all around the little minuses or the pieces of fruit, they thought would be positive. Now, that's incorrect. At this point, we know that you have the protons in the nucleus, but they didn't know that yet. We can't see it in the microscope. We're learning through this experimentation. And so here we have the chocolate chip cookie or plum pudding model. The chocolate chips are the electrons. The cookie would be the so-called positive medium of the atom. Okay? So these little pockets of negatives, these little corpuscles of negatives. Now, we're going to move on to another man who did another experiment, the gold foil experiment. And this is actually, this experiment was done by Rutherford. And through this experiment, he actually shot out positively charged, positive alpha particles. And you can see where it says radioactive source. He's shooting out these alpha particles, and they hit a gold foil. Now, due to the knowledge of what J.J. Thompson and Crookes did, Rutherford basically thought, okay, those bullets would pass straight through, okay, and maybe be attracted to the negatives and go straight through. What he didn't expect was when he shot an alpha particle through, an alpha particle would, some of the times they would go straight through, but sometimes they would reflect or bounce off, and they would go in different directions. And as they bounced off, Rutherford figured out that those positive alpha particles were being repelled from something that was very strong that was also positive. So instead of just having a mass or the cookie or the um, the cake of positive, you would have some sort of center, strong positive structure that caused, if a positive alpha particle went through, hit directly on, it would come right back. If it clipped maybe the side of the positive part, it would maybe bounce diagonally. So this experiment proved that the protons, the positive parts, were actually in the nucleus. Instead of being negative and then in a mixture of positive, he thought that there was some center positive like a nucleus. Okay. Now we do know that there are also neutrons in the nucleus, and neutrons do not have a charge. And basically there was another experiment done. We're not going to focus on that though. That was very similar to the gold foil experiment. I'm not going to focus on that right now, but you should be aware of these experiments are helping us discover and identify the parts of the atom. Now even today, if we have an electron microscope and we look at it, and we see an atom, it's just going to look like a little ball. But we know it has these parts because of the experiments that are done. Now moving on to Niels Bohr. Niels Bohr was a Danish scientist, and basically he came up with the Bohr model, and that is which identified a level for each electron. And something that you're probably going to learn in high school chemistry is that there's different levels. There's outside levels called valence electrons. So there's different orbits. So they called this the orbital model, or the Bohr model, because it resembles the planets going around the sun. So he came up with a center nucleus based on what Rutherford discovered, having the positive protons in the nucleus. Well, he's not just having a electron outside, but he's specifically putting the electrons in certain orbitals or certain levels. And then moving on, I'm going to end with the basic idea of the wave model, saying that the electrons don't really move about and around the atom in a definite path like planets around the sun, but they actually have a energy. So instead of it just going in a direct path, they have more of a probable location of the electron based on how much energy the electron is given off. So they're kind of moving all kind of over in a designated path, but not in a set path. We're still learning. We're still figuring out about the atom. Some things that we're finding out, we're able to increase our knowledge, build off of other knowledge that is wrong. And so if anything that you can take from this, we know the parts of the atom. Okay? We know that there is a nucleus, there is a middle. We know there is a positive proton based on what Rutherford discovered. We know that there is a part in the center called neutrons that really doesn't have a charge from another experiment. And we do know that there are electrons in some sort of outside energy cloud, and these electrons are negative. And how do we know that? Okay, not necessarily from us being able to see it, but through experimentation and also just by scientists hypothesizing what they think, okay, these models may look like. Could we be wrong in what the atom looks like? Could we, in maybe future technology, be able to figure it out and change? Yes, science is always changing. So just be prepared that what you read in the textbook, what you hear or think about in maybe from movies or whatever, it doesn't necessarily mean that's actually how it is. We're taking our limited knowledge, even though we have some great technology, but our limited knowledge to identify the parts of the atom.